Hi and welcome to DCO. My name is David Copete. In today's video, you'll see a full tutorial where I'm going over all of the steps for creating this design. This is a wavy ceiling design that is an array, and at the end, you'll see that we also create the clips. So it has two different tutorials in one. First, how we create the form, create the array, create the depth for the contours, and then, like I said, the clips for hanging these onto a wall or part of the structure. So this is what you'll see if you download the script to see how it was made. You'll see that this is going to be the script where all of the steps are organized as you see in the video. Then you'll also be able to download the cluster, which is the simplified version. And then you'll also see the other work session script. So I wanted to make sure that you guys have those available to download. Why? Because there are different steps that I created for the work session, and you'll also see that at the end. So thank you for being here. Hopefully you're excited to learn a few more tricks, a few more techniques, and a lot of the things that you'll see in this script can be applied for other designs, not just the ceiling design. So like I said, thank you for being here, and let's jump right in. All right, so the first thing we're going to do in this script is bring in a rectangle. So I'll double click here, bring in a rectangle component. And by default, we can just create a rectangle, but if we want to be able to change that location, we can bring in a parametric point. So I'll go here to construct point. Then with this parametric point, we can use that as the input, but I like to route it through an empty point component. This way we can always change that location by setting one point and then plugging that into the rectangle. So with this rectangle component, we can now change the X and Y. So I'll go here to 240 and create two different sliders. Now the number of the sliders is going to depend on the units that you're using for your file here. 240 is going to work for this exercise, and obviously we can change that here using the different input. The next thing we're going to do is take that rectangle and move this up, since this is going to be a ceiling design. So the first thing I wanted to do is create a reference of where this is going to be the lowest point at. So I'm going to use the rectangle as the input for the move, and a Z vector to move this up in the Z direction. And I'll just copy one of these sliders over, tapping Alt. So this way we can create the lowest place where the pattern is going to go down to, or at least have a reference of where the lowest number is going to be. Then we're going to create the height of where the variation of the waves can go. So I'll take this, slide it over, tap Alt to create another move. But this one, I'll use a different slider. Actually, let's make this a little bit bigger here. Now this is where the wave is going to vary up and down. Now the next reference rectangle that I'm moving is going to be the height of where the pattern is actually consistent. And you'll see that when you create a wave, you don't want to start right at the base. You want to actually have a space where it's consistent. So I'll bring this over, and this will make a little bit more sense later on down the script. And we'll go here to, let's say 12. Or even less, like 6. And this one we'll do 24. So this is going to be clear. Here's going to be the wave, and then here's going to be a solid portion. So now where we want to create the surface and the wave is going to be on this rectangle. So what we need to do is bring in a surface. So we'll use a boundary surface. and create a rectangle right at that polyline. Next, we need to subdivide this so we can create the wave. Now, there are different ways to do this, but in this exercise, I'll show you first using divide surface. So this is going to let us plug in that surface into the divide surface and create an array of points that subdivides that surface. Now, the subdivision for a surface is going to be U and V. So here, we'll be able to change that with the slider. So I'll create two different ones. And now we're going to take those points and move them down to create the wave. So first, what I'll do is set up the move component, plug in the points into the geometry input. Now notice this dashed line, which means these are grafted sets, which means grouped sets rather than a long list. So we'll flatten it so we make sure that it's all in one list. Same thing with the normals here. We'll flatten the output. This way we can use the normals, which is perpendicular to the surface, to move these points. So for that, I'll use amplitude, which means we'll use the normals as a vector, the vector as the motion, and now we can move these points. Notice that it's moving in the positive direction. So we'll go here to, let's say, 12.5. And since they're going up, well, we're going to change the direction by bringing in a negative component and changing the vector direction to go down. Now notice here that all of the points get moved by one number. And we don't really want that. What we want is for all of them to be moved down randomly to be able to create that wave effect. So what we'll do here is move this over. And rather than having just one number as an input, we actually need 36 different numbers that are random. And we can pick the range. So let's go here to a random component. This will let us create a random set of numbers. By default, it'll have one number that is randomly created between 0 and 1, and the seed is 2. So what we need to do is plug in how many points we have. So we know we have 36 here, but we can't just plug in 36 into the points into the number because the points are not numbers. So we need to bring in a length or a list length. And this component, whatever number of inputs it has, so let's say it has 36 points, it's going to just give us a number as the length. So 36 is going to be how many we're going to create. Now you'll see that it creates 36, but it's between 0 and 1. So we need to change it, the range, for it to be a specific number that we pick. For that, we'll use construct domain. And now here, what I'll do is I'll unplug the amplitude on that and use two numbers, 24, and then it could be 0, but I like to use a little bit more. So I'll just go 3 and 24. Now we'll plug in 3 into the start and 3 and 24 into the end, but it could also be the other way around. It could be 24 and then 3. Since we're creating random numbers, it doesn't really matter. But let's just keep it organized. We'll go between 3 and 24. We'll plug in the domain into the range. Now when we look at the random numbers, we're getting 36 random numbers between 3 and 24. And so this is just one iteration. If you think about it, when creating random numbers, you can actually have like an infinite number of random sets created here. So to be able to control that, it has a seed, and by default it says 2. So we'll create a range between, we'll just create a slider of 10. We'll set it at 0, and we'll say that seed of 0 creates these numbers, but notice that the first one is 18, Now, if we change this, the first one's going to be 9. So it'll just create random solutions to the random numbers. So now we can plug this into the amplitude. Notice that now we're getting the effect that we're looking for. They're moving down randomly. But one of the things is when it has all of these decimal numbers, that's totally fine because it's just moving it up and down randomly. But something I want to show you is you can also set it to integer numbers, which means it'll do whole numbers as the numbers that it creates. So by changing that and changing this, you'll see that we get random points. Okay, so at this point, we move them down randomly. We probably don't need these points. And all we need to do is create a surface at those points, which is the reason why I use the divide surface, is because using it with surface from points, we can actually create a surface that is created based off of these points. So we'll use the geometry or these points as the points input, but this is, I'll show you why this is not going to work, because it's asking us for a U count. Now the U count, you would say, okay, well the U count for the surfaces is 5, and if we plug that into the U count, it should work. But the reason why it doesn't work is because of this. When you divide by 5, when you look here, you actually have 1, 2, 3, 4, 5, 6. It subdivides it into 5 even spaces, but it actually gives you six sets in the U count. So what we need to do is take this number in the U, 5, and add 1. So I'll go here to +1. Actually, let me double click here, do +1. And notice that here on top, it says addition. And when you do +1, it'll bring an addition component setting B as 1 by default because you set +1. And then you can plug in 5 in the A. It's going to add 1 and it's going to give us 6. So now we can use this to set the U count. And notice that now it creates that wave surface, although by default, it's going to not interpolate through the points, which means that it's not going to go through the exact points here by default. It says false. So one way to change this is you could have 2 different ways of doing this: interpolated and not interpolated. In the same way that you could have a interpolated curve or a NURBS curve. So here we'll set between 0 less than 1. And we can use 0 for false and 1 for true. But notice that when you set it to true, it's actually going through those points and it makes the wave more drastic. So with this, we have control in terms of making it not so wavy and making it more wavy. Also with the points here, we have controls in terms of creating more points and therefore exaggerating the wave pattern here. And then we have the control between the smallest and largest numbers, and we can also make this the lower and this one the larger number. Now this line segment, I was using just as a guide. So if we see that it goes too far past it, we can always bring it back. Now, in some cases, it just goes a little bit, but this is going to ensure that you can see and you can control how far things go. And if you don't like this wave, well, you can try a different number for the seed. So now here, what we're going to do is this. We're going to disable the preview on most of this stuff. Trying to keep it organized so you see what happens here. But you can always, if you get lost or if I'm going too quick, you can always download this and see how it's plugged in. Okay, let me lower some of these. And also you can make it wavy in one direction and not in the other. Those are some of the cool things here. We'll just keep it simple, 4 and 4. Minimum and maximum, we'll just increase this a little bit more. All right, so for the next step, what we need to do is turn this into a solid by starting here at the top and then using this as the bottom face. So what we'll do here is project the outside line segment to the top. So here we have the surface. When we plug that surface into a curve input, it'll extract just the outside line segment. Now we can also just project the entire surface, but to keep it simple, we'll take that outside line and project it up to this location. So next we need to figure out that location, which is going to be at the top here. When we move this one all the way up. Now here's the thing. You may think that we can just use this edge to loft with this one, but that sometimes doesn't work. Sometimes that, let me show you what I mean. Lofting this curve and this curve. And if we flatten the input. So in this case, it is working, but in some cases, like when we change this a lot, let's see. Sometimes that doesn't work. Now, I almost don't want to show you the other way of doing it, which is going to be by projecting this curve up. So now this one is working for me, but I've had it the case where the polyline at the top is organized in a different way than the edge, and therefore that messes up the way that it lofts. So we'll keep it like this for now. In the work session later, you'll see a different direction that I took. So now with this and this one, we're going to join it using brep join. So it'll be that bottom surface as the first input, and then the loft here, which I will use a hidden wire display because it's coming from all the way over there, as holding down shift and adding this as another input. And now using this line segment, I'll create a surface. So instead of bringing over a boundary surface all the way over here, I'll actually just double click here as the input, or as the, I'll just create a surface here. So I'll go to boundary surface, hide the wire, and bring this over to here. And holding down shift, I'll add another input. So when I hover over the output, it says 2 values for the breps. So I'll flatten the input and actually use, and then you'll see that it's 1 closed brep. Now we can double check this by baking it and bringing it over to the side. And so this solid is going to serve as the overall shape and form of where we're going to be creating the array. So notice that we still have some things overlapping here. So we'll hide this surface. We'll hide this surface. We'll hide this surface because now we've joined it. And we'll hide this one. So now you see why we created the different steps. This is to reference the lowest points. So here we can look at it from the side view. And then here you'll see that this is the minimum. So sometimes it goes into it. So we will raise this number. Why? Because in many cases, when you create this array and you manufacture it, you want to have a minimum length that you have here. Otherwise, you run the risk of like snapping one of the verticals or one of the arrays. So I'm going to go back to less. Okay, I think that looks good. The next step is, now that we have the form, is extracting the geometry as a set of arrays, either in the X direction or the Y direction. I'm going to show you just doing it in the X or Y. In the work session later on, you'll see that you can actually change the vector, but that's going to cause some conflict on where you can actually hang these from. Because I envision this, whatever way you create the array, at the ends you would have some kind of bracket that can connect the array to a wall or a ceiling, or maybe even a beam or something. So let's get into the next portion. Now here we need to create a set of contours. So what we need is to bring in first contour component. Now for this component, we're going to need the shape, which is going to be this one. The point of where the contours start, and typically that's going to be the center. So here's the thing. A lot of people that use Rhino 7, and I use Rhino 8, but when you use Rhino 7, there's a discrepancy between the area component. So what I use instead is a discontinuity, which gives you the points at the corners where it turns. So we have 4 of these. And I create an average between those, giving us the exact midpoint. So I'll be using that midpoint. I'll bring it all the way over there. And when I bring it over to a location that's way over there, I go to wire display hidden. This way, I don't have just this weird wire just looking all disorganized. This is going to be the midpoint, which is where we want it to start. The direction is going to be here in the X or in the Y direction. So we'll go here to unit X, but I'll also bring the unit Y just in case you want to pick a different one. And the distance is how far spaced out each contour is going to be. Now, I do like to limit this to a minimum number. So I'll go to 3, because when you get too low, let's say 2.1, it'll create so many that it can crash your computer. So this is something to keep in mind. So notice now that it creates a contours of, in the X direction, through this shape, starting at the midpoint and spaced out by 8.5. Now for the contour, I'll use a shape or a surface. So I'll use boundary surfaces. And I'll hide the contours and I'll hide the shape. So even just with this, you can take these contours and array them in a way that you can, or not even just the surfaces, just the contours. You can array them in a way that you can cut them with the CNC. But what I want to show here is what it would look like with the actual depth of each contour. So first I'll flatten the output so they're all in one list. Then move or create an extrusion here. But here's the trick that I use. I move it halfway in one direction and then multiply by 2 in the opposite direction, leaving this as the midpoint. So to do this, since we're doing it in the X direction, I'm actually going to be using an amplitude component, because depending on whether you use the Y or the X, we can be consistent with the same direction that the contours are made. Then the thickness or the depth of each contour will just go to 1.5. But since this is the midpoint, we actually need to do 1.5 divided by 2. And you'll see why this is critical. So we'll go 1.5. We'll just make it 2 here, so to kind of show you the idea. Divided by 2 is going to be 1. And so we'll move it by 1 in the X direction. And now that we moved it by 1, we want to extrude by 2, which means 1 times 2, and then in the negative direction. So we move it out here and extrude it by twice as much in the opposite direction that we moved it. And this is why we need to divide by 2, is because we're going to be multiplying it by 2 to get the overall depth. So if this was 1 and we didn't divide it by 2 and we multiply it by 2 to keep it centered, it will actually be twice as much as what we have as the input. And we want the slider to reflect the actual depth of what we want the contour to be. Now we can also offset it by half to one side and half to the other, and then loft it together, but this is more optimized. So we're just doing a movement and an extrusion, and then keeping this, the original contours, as the center. Now we can bring in a custom slider now. So I'll go here to custom, preview, use the material or a color swatch. Now there's different ways we could do this. We can do material, but I like to use this color swatch because it's a little bit smaller and it kind of gets the idea. Now if it's going to be wood, then I like to kind of represent that here. So now let's hide the extrusions. Now let's see what it looks like when it has more subdivisions. So when you lower this number, there's a smaller spacing, which means more. So 5.5 or 3.5, which is one of the smaller numbers you can have here. And it creates 69 contours. And we can always change the number of subdivisions. Let's say 10, and then 10. And then we can make it so it's not so drastic by changing the interpolate. We can also change the minimum and maximum, so we know that we have this guide here. So maybe here on the sides, it's okay if it goes a little bit lower. And then here, it's okay if it goes a little bit higher up. Now we don't want it to go so thin where it'll break, but also we can change the randomized set of point movements. And so we have an infinite amount of iterations that we can create just for this design. And so that's one of the reasons why I love parametric modeling, is because you're not limited by the idea. You can explore the idea further by changing the inputs of what you thought would be just one and create an infinite number of them just by changing a slider here. Now, here's the other cool thing is if, let's say we change the U count to, let's say 20. We can also do the ripple just happening in one direction. So we'll do 3 here, and then we'll just change to 20 on this direction. And then interpolate it by yes. And so notice that now the wave happens in one direction. We can also change the maximum and minimum this way. So there are a lot of ways to explore this script. I think this is a great exercise if you're fairly new, or if you're into fabrication, into interior design, architecture. This could be applied to a wall. So now for this next portion, what I'm going to show is how to create the brackets at the end here. Now this is a little bit more advanced, but I'm going to be sharing all of the steps so you can see everything from beginning to end here. So let's lower the subdivisions by changing this to like 12. And then I'll go back to the surface. I'll hide the output here. I'll know that this is the number of the overall width of it, so we can use that for the bracket as well. And I'll use the distance here of, let's just go 8.5. This way it lands a little bit to the inside. All right, so what we need to do now is find the top surface, which is going to be this one. And this one we have not turned into a surface yet, so we will do that. I'll copy this over, turn that into a surface, preview it again, and bring it over to the contours that I created. I'll hide the wire because it's from all the way over there, bringing it over. And now, rather than contouring the overall form, I'm going to be contouring that surface. So notice that it'll land in the same location because we're sharing that distance here. If I said 7.5, well, it'll create this one as well. So now I can hide this and just bring back this. So these are going to be the contours that have the thickness to them, and then hide that surface at the top. Now what we need to do is this. Let's see if I can annotate it here, because I have this annotation thing. Let's see if it shows up. Sometimes it works. Let's see if it shows up. There it is. Okay. Let's see if I can. So we're going to be taking this point. Let's turn it to a different color here. And then we're going to, actually maybe a little bit bigger. This point, we're going to move it to the right. I'm going to move it to the left, creating those points, and then creating a line segment and offsetting that to create the bracket, which will be here. Then extending this line segment to each side Why? Because that will create this location or this bracket where it can connect in here, it can connect on this side, and then this part of the bracket can connect into the wall. So hopefully you're able to see that. Let's actually delete some of this stuff. So bear with me, I'm just learning how to use that tool. Okay, so we have all of these contours. Now we can do it all at once or do it to one and then do the same thing to all of them. So this is why I flattened the contours here, because now we're bringing and pick just one of them. So I'll go to list item. When you go to list item, here you have 29 different contours. Here we'll use just one of them, which is index of 0, this one, the first one. And now we'll get the endpoint. So there's the endpoint, the start point, and the endpoint. So this is going to be, let's see here, just the start point, which is this one. Now there's the other endpoint, which we'll need to do as well, but we'll start with this one. And then move it in the same direction as the contour. So rather than just bringing in another X vector, I'll use this amplitude. Why? Because if I change the Y direction, then I want to be able to be consistent with whatever direction the contours are made in. So what I'll do is I'll go to this vector, this number, and the division by 2, and I'll actually copy this without the 1.5, and you'll see why. Now we'll take this and move it by that amount, which is the same amount as half of the contour. So that's already taken care of by the half. Then I'll hide the input here because notice how it gets really messy. And you can always select it and see where it came from. So if you're getting lost, go ahead and download this from my site and you'll see how things kind of plug in here. Okay, so we have it in the positive direction, 0.75, and now we'll go to a negative direction. So we'll copy this, change the vector to the opposite direction by using a negative. So now we have these 2 points, and we can hide both of these just so we don't see it. Now we'll need to see that again, but for now, using these 2, I'll create a line segment between the start and end point. Now to create that bracket, we need to offset it to this side, to the inside. So offset. And when you offset something, it's going to go perpendicular, so we don't have to give it a specific change of vector or anything. With the line segment, now we know it's going to go positive or negative. Here, it's going +1. So we'll actually go to a negative and then use a number to create the size of the bracket. So this is up to how you want to manufacture this. We'll go 2.5. So we have the line, the offset, and so what we need to do is create a connection between the endpoints of this and the points that we have here. So using an endpoints component, we can now connect this one to one of these 2 using a line segment. So this one to start, this one to end. So this first point is going to correspond with the start point. Now, obviously, if you use the endpoint and you see it like this, well, that's the wrong one. So you'll visually be able to see that connection. And then copy that line segment and do the same thing with the other point, which is this one, and connect it to the endpoint. So now we have these 2. as well as this one. And so now we can join those into one closed polyline. Now here's the thing. We're going to, yeah, let's do that. I'll show you the trick here. So first, this one. Then the middle one, holding down shift, I'll add the other input. And holding down shift, I'll add the last one. When you hover over the output for the join curves, notice that it says 3 separate ones. So when we flatten the input, it makes sure that it's one list. And then when you look at the output, it has one polyline, and we can double check that by baking it and seeing that it's a closed polyline. Now we're going to offset this to the outside. So we'll go to offset curve. And then this is going to be the depth of the bracket. So now depending on what material you use, I'll just go and use the slider here. So now we have this line segment that's been offset. And so now I'll bring in the endpoints of this one, of the offset, which are going to be this one, and connect it to the endpoints of this one, the start and end. So using a line segment, I'll use the start connecting to the start point, creating this little bit, and the endpoint connecting to the endpoint. So the start and start points connect to the start and end points of this line, and the endpoints of those two connect to the start and end. Now, it doesn't really matter in what direction you put it or in what order you put it. You can put this endpoint as the start and this one at the end. What matters here is that when we have this, let's see, I think it's fine like this. If we join it, so joining this inside line for the inside bracket, joining this outside line with these two. So holding down shift, I'll add those two little bits to close the polyline, and then the outside one. Now we can look here at the output. It says 2 curves. So we need to flatten the input the same way that we did it with this one to make sure that they're all plugged in as a list. And it'll say one closed polyline, which if we bake this, we can see that that's the bracket that is based off of the original contour size plus the bracket size, including how far we want this to go. So this is going to be the depth of the bracket. This is going to be how far in. So sometimes you want this bracket to, hang off of a wall here. So it could be, deeper. But for now, we'll just make it at 3. And here's the important thing, that when we go to graft, so the list has 29 of them. We're just picking one. But if we graft this one, oh, that flattened it. If we, instead of flattening it, we graft it, that it does it for all of them. And it does. So we'll go back to just that one. And this could be enough, right? Like if we take this and extrude it down, it could be designed in a way where, let's bring this back, to where if this bracket goes down to here, you can have it be, let me rotate around and explain it better. So if this was extruded down, it could be designed to where there could be holes here that anchor into the wall, and then this could hang from here and like this. But in my opinion, it would be better to create a bracket that extends on the outside here so it can connect on the outside, and then there's no conflict between being able to hang these after. So, and that's how I have the work session kind of designed. So you'll see that later. But for now, let's go back to this line segment. And now let's create that back side of the bracket. So we've got this line segment that represents the depth of the contour here at the edge. Now what we need to do is expand it to create the bracket where we're going to connect it to the, to the side here. So we'll go here to extend curve. Use that as the input. Now we'll extend it by first, if this is, we'll just say 0.5 or that's too much. 0.1. First, it'll be 0.1 and you'll see why. So it'll extend it to here. And then if we want this to be the exact number of size, it'll have to be 0.1 plus. So I'll undo this. I'll use a plus. And with the plus, it doesn't matter where you plug it in, but I'm going to plug in the 0.1 as B. And then have A be the size of it. So I'll go here to 2.5. So now this is maybe a little bit too much here. Just do 1.5. And so what it does is it adds 1.5 plus 0.1, and it's going to extend it by 1.6. Why? Because we're accounting for the depth of this. Now we can take this curve, offset it again. So I'll use this one. And it'll offset to the outside, which is what we want. Now we need to get the endpoints of these two and connect them the same way that we did these. So using endpoints. Now this one might be different because we need to create the endpoints both for this one and for this one. And connect them with the line segment. So I'll go here to line between the start and the start and the end and the end. Now using these two, I'll connect them with this. So we're creating closed polylines. So I'll copy this and override it with this one, holding down shift, and then this one. Now here we have a closed polyline. So rather than when we extrude it doing Boolean union, which can be inefficient for the script, we're going to use region union between this one and this one. Now notice that it'll join those together, which is what we want. And now all of this portion of the script can kind of be hidden, right? Because now we've got the depth of the bracket. We have the depth of the material, and we have how wide this is going to go to connect to the wall. So now here we could create a surface and extrude it down to create the bracket height. So extrude Z negative to extrude down, and then use a number slider for the depth. So let's go here to Now, this can correspond to this offset between these two. Why? Because that is what we want it to be consistent. And so therefore we know that it'll hang on a portion that we know is not going to be like too high up, because we made sure that we know what the smallest number is going to be. So we're almost done here, but there's still something that you'll see that is a bit tricky here. So, okay, we've created the bracket. Now let's go here and graft this. Notice that it does it all, but it does it all to one side. Now, we can use a mirror command or a mirror component and mirror this to the other side, or we can also create all of this the same way that we created this, but on the other side. And I think, although we can mirror it, I want to show you how to be able to do this, because it's a bit interesting to see how that works here. Okay. So first things first is all of the components except for the sliders. So now let's just, I'm going to show you, we're going to copy all of this down. The portion of the script that creates the brackets. And now I'll use the endpoint as the point input. So what we see here is that it actually did it to the other side, which means that this offset has to be not negative, but it has to be positive. So I'll override using the slider up here. This is so you can see it. Okay, so we got that. Now we're seeing that this is offset to the wrong way. It needs to be offset to the other side. So this number, which is this one, needs to be a negative. So I'll go here to a negative component and use this as a negative. And I created a relay because we have more than one place where that happens. So now we've got that in the negative direction. Now on this one, we have positive 8. And on this one, we have negative 7. So this is good because that's the same as this one. Now we need to see where this offset is. So it offsets to the right location here. So it's offsetting this to the inside. That's this one. So it needs to be positive. So not negative on that one. Then we have this one and this one. Those get brought together here and get extruded down the same way. So now everything is working together. Now the only thing that's not looking good, in my opinion, is some of the wires here. When you bring them over, they're going to get in the way. So I'll go to hidden. Now this is a number. So I'll bring in a number empty component, hide the input, plug this in, and then use this instead. It kind of keeps it more organized here, in my opinion. We can also hide the input on this one and on this one. So rather than mirroring it, we can also copy the steps to the other side. And just use the same slider. So 7, well, we don't want this to be a separate size. So we'll share that one as well. So what we're doing here is copying the steps and making sure that we are sharing the same inputs, so that way it happens the same way on both sides. Now, what's more efficient, doing this or mirroring it? Well, here's the thing. If you have a wall or a polyline that is not necessarily the rectangular, then you can't mirror it. If it's not symmetrical, then you can't mirror it. So this will ensure that no matter what, it does it on the other side of where the contour is, no matter what. So now let's do this. We got 2 sets of brackets. Now, of course, we can also go in here and create the hole for it. But that's, that's something that we're not going to do in this one. I just wanted to show you how to be able to create the brackets to hold the contours and how to create the contours with a random array like this. So let's go to these two. I'll plug both of those into an empty geometry component. Hide the input or hide those. And then out here on this one, also use a geometry component. This way you can see, and I like to group that component so we can see the actual component that creates the objects that we want to preview. Then we'll bring back this preview, hide the input for the geometry custom preview, and then copy this over to the end here, this custom preview, and use that to color the brackets. Now here's the trick on this, is the more contours you have, the closer you'll get to the actual shape, the original shape. So let's lower this to, let's say, 6. All right, so that's going to conclude the tutorial. What I'll do now is clean up the script by the inputs and outputs. I'll be labeling them. And like I said, if I went too quick, or if there's a place where you got lost or you got stuck somewhere, you can download this and see where and how things got plugged in. But also let me know in the comments below if you enjoyed this tutorial, if you got lost somewhere, if you have any questions, or just in general, if you have ideas for other scripts. So thank you very much for being here. Hopefully you learned something new and interesting here. A lot of the things that you learned here can probably be applied to other designs, not just this particular ceiling design. And so thank you for being here, and I hope to see you on the next video.